Hello everyone. I would like to talk about inequality principle in electromagnetism and with a little comparison to equivalence principle in general relativity. The inequality principle for the first time is mentioned in a preprint under the title Confinement of Gravity within Electromagnetism based on intrinsic electric dipoles. If we make a small comparison between these two principles, the inequality principle and the equivalence principle, the equivalence principle can be demonstrated by a simple experiment, which is an elevator experiment. You can feel the change of the weight you can feel inside the elevator with acceleration and deceleration of the deceleration of the elevator. You can feel the change of the weight, which is you can test the equivalence principle inside the elevator. In comparison, for inequality principle in electromagnetism can be demonstrated by a simple experiment, by a ball marble magnets, permanent magnets. If you have according to this preprint, if you have a ball and then you have a marble, and both of them are composed of or made from permanent magnets, and these in order to produce repulsion, these two bodies, these two permanent magnets, the ball and the marble, should be in the straight line, and both of them should be prevented from both horizontal and vertical rotation in order to see the repulsion. And that's so the repulsion is not easy between them. It should be arranged the direction and also for example north to the opposite north, and the marble and the balls, both of them should be prevented from rotation, both horizontal and vertical rotation. In all types of rotation. So by a simple experiment, for example, if you make a ball, if you have a permanent ball, a permanent magnetic ball, and another permanent magnetic in the shape of marble, and there's a hole in the center of each of them, and if you put them in one line, so you notice that the attraction is easily can be achieved. Because even if the north is opposite the north and the south opposite the south, the marble or ball or both of them will try to rotate and make attraction. While if we prevent both rotation and horizontal and vertical rotation of the both balls and marble, and if in a position when there's a north is opposite to north, we can observe the repulsion. While for attraction it's easy. For attraction is easy. You don't want to prevent them from rotation, or even if they are not in the same line. So this is the inequality. So the attraction is easily achieved, while repulsion should be maintained. So there's inequality between attraction and repulsion in electromagnetism for the dipoles. And of course, the permanent magnets are multipoles actually. So same thing true for electric. Same thing true for electric dipoles. If we have electric dipole inside. If we have electric dipole inside an electric electric field, for example, here we apply the positive, for example, voltage in. If you the same thing true for them, at the repulsion of this electric dipole inside this electric field is repulsion is difficult, more difficult than attraction. So by this principle, inequality principle, we can explain an experimental data of a paper which is published in 2005 by a few American researchers under the title, the papers published under the title Experimental Indication of Electrogravity. And they have the data as like that. When they applied, you can read about the paper online. So if they applied, if they didn't apply any voltage, they calculated the weight of their test mass. And if they applied a negative voltage, the weight is changed slightly. And if they applied a positive voltage, also the weight is increased slightly. But according to the data of this paper, increasing in weight in the negative voltage is less than that of the application of the positive voltage. So this phenomena, this data in their experiment, can be explained by inequality principle in electromagnetism, in which when they applied a positive voltage, the electrons, which are the conductor, they used a metal, which are the conductor, and there are cloud around the nucleus. The nucleus, or the nucleus is repulsed by the external electric field, while the electrons are attracted. So this is, in this case, the attraction of electrons happening, while the repulsion of nucleons happening. While if they applied a negative voltage, the reverse is occurring. The dipoles become like that. The nucleus is attracted toward the negative voltage, while the electrons are repulsed from the negative voltage source. In this, what is the difference in both scenarios? The test mass is attracted toward the electric field source, but it was more in a positive voltage application than in a negative voltage application, because the electrons were playing major role in this both sides. So in case of positive voltage, the electrons are attracted, but in the case of application of negative voltage, the electrons are repulsed. So these are unequal, and this inequality, the attraction of electrons is easier than the repulsion. That's why by application of a positive voltage, the weight is increased more than the application of negative voltage, and in the application of negative voltage is the weight is more than that of application of zero voltage, or there's no voltage. We can go further. For example, if this is first step experiment, this is a second step experiment which is done by these researchers, experimental indication of electrogravity. However, they didn't explain this change, and I think, as I understood, they didn't provide any explanation for this difference. But the preprint confinement of gravity within electromagnetism based on intrinsic electric dipoles can provide the explanation for this difference, and which is by inequality principle. The third step for inequality principle, we can test inequality principle by using an oscilloscope with single electrode. So if we have an oscilloscope where the electron beam is, for example, is like that. If there is no, if this is if we regard this as single electrode, we draw it as a single electrode, and this is an electron beam. So if we apply an AC current to this electrode with the variable frequency and variable voltage, we can notice that because of electrons also have intrinsic electric dipoles, electric dipole momentum they have according to the standard model of physics. So their repulsion and attraction is not equal, and according to the frequency, maybe, for example, according to increasing the frequency and the voltage, there may be a curve like that, the electrons will be attracted to the electrode. And this is only can be explained by inequality principle in electromagnetism. And another setup for this experiment, if you have an oscilloscope with a single electrode, but with multiple electrodes this time, but each electrode is adjacently arranged like that, negative, positive, negative, positive, negative, positive, with a variable voltage. But of course, you know, this is DC, not the DC voltage. So with variable voltage, we can notice that also because of electrons here repulsed from the electrode and here are attracted, because of the same phenomena, same principle, inequality principle, the repulsion and attraction they are not equal. So at the end, the electron will be slightly curved, and it will be slightly curved toward the electrode, and this is only can be explained by inequality principle in electromagnetism, and this can be the only method for measuring the electric dipole momentum of electron. And in this case, we can just use an oscilloscope with high accuracy, other than accelerators or something more sophisticated, for more sophisticated instruments. Thanks for listening. I'm hopefully waiting for your comments and critiques, and for your support, of course, because this is in this preprint. Our preprint is in the early stage, and we need your feedbacks. Your feedbacks are important. Your supports are important for us. Thanks again. Have a good day.